Hi guys, today we're going to be talking about vectors. What is a vector? A vector is a quantity that has magnitude, which is size, and direction. The length shows the magnitude and the arrowhead shows the direction. Vector representation. Vector AB is the vector going from A to B. A vector can be represented three ways. One, as two letters with an overhead arrow, like this, or as a lowercase letter, like this S here, or three, as a column vector or column matrix. X goes on top, Y goes below. And over here to the right is a diagram showing vector A, B, and you also see the lowercase letter S. What are vectors used to represent? Vectors are used to represent physical ideas such as velocity, force, momentum, weight, acceleration, displacement, etc. Gravity is a vector quantity. Its size on Earth is 9.8 meters per second squared, and its direction is downwards. Operations on vectors. Vectors can be added, subtracted, and multiplied. Addition of vectors. Add the x parts and then add y parts. For example, vector OA equals 5, 6. Vector OB equals 5, 2. U is equal to vector OA plus vector OB. Solve for U. So they give you U is equal to vector OA plus vector OB. So you simply take vector OA, which is 5, 6, and you add vector OB, which is 5, 2. So as I said up here, you add the x parts first. So 5 plus 5, you get 10. 6 plus 2, you get 8. Therefore, vector U is equal to 10, 8. Triangular law. Triangular law of vector addition. When two vectors are represented by two sides of a triangle in size and direction taken in same order, then the third side of that triangle represents the resultant of the vectors. So you see here, vector A is going in the same direction as vector B. Therefore, we get the resultant of the vectors here, which is vector A plus vector B. Parallelogram law. Parallelogram law of vector addition. If two vectors are considered to be the adjacent sides of a parallelogram, then the resultant of the two vectors is given by the vector that is a diagonal passing through the point of contact of two vectors. So you see here, vector A and vector B are next to each other, so they are adjacent, and their point of contact is right here, this point right here, and you see the diagonal is passing through it. Passing through this point right here. And that is the resultant of the two vectors. Subtraction of vectors. Reverse the vector you want, then add or subtract the first vector from the second vector. For example, vector OA equals 5, 6. Vector OB equals 5, 2. V is equal to vector AB. Solve for V. So they told you V is equal to vector AB, and we know vector AB is equal to vector AO plus vector OB. However, we were given vector OA, not vector AO. So what we do is we take the negative of vector OA because vector AO is going in the opposite direction. That's why we have to take the negative of it. So instead of saying 5, 6, we now have negative 5, 6, which means negative 5, negative 6. And we have to add that to vector OB. So we get negative 5 plus 5, and that is equal to 0. Negative 6 plus 2, that is equal to negative 4. Or we can do the second part here, which says subtract the first vector from the second vector. So the second vector is OB, so we have 5, 2, minus the first vector, which is OA, which is 5, 6. So now we have 5 minus 5, we get 0. 2 minus 6, we get negative 4. So phi is equal to 0, negative 4, and you see we got the same answer for both methods. Therefore, we know the answer is correct and both methods work. Multiplication of vectors. 1. Using a multiplier called a scalar. W equals K times the vector OA. This W here, you could use any letter. This is just what was given in this case. And K is always used to represent the multiplier or scalar. And this is the vector here, vector OA. For example, vector OA equals 5, 6. If A is equal to 3 times vector OA, that means A is equal to 3 times 5, 6. So just replace vector OA by what was given, which was 5, 6. And now you multiply the scalar by x and y. So you go 3 times 5 is 15, 3 times 6 is 18. Therefore, A is equal to 15, 18. Second method is dot product. The answer is always going to be scalar for a dot product, which means it's just going to be a number. So dot product of A times B is equal to everything that's in A, which is A1, A2, A3, dot everything that's in B, which is B1, B2, B3. And that is equal to A1, B1 plus A2, B2 plus A3, B3. For example, vector A equals 2, 5. Vector B equals 7, 1. So the dot product of A and B equals, so it's A1, B1, and A1 in this case is 2, B1 in this case is 7. So you do 2 times 7 plus A2, B2, which is 5 times 1. And 2 times 7 is equal to 14. 5 times 1 is equal to 5. Therefore, 14 plus 5 is equal to 19. So the dot product of A and B in this case is equal to 19. Note, two vectors are orthogonal only if their dot product is 0. So the dot product has to be 0 in order for it to be orthogonal. And number 3, the cross product. If A and B are two vectors, then the cross product or vector product is a vector V, which is equal to A times B, which is equal to V1, V2, V3. The vector V can be obtained from the expansion by the first row of the symbolic third order determinant. So if you remember from previously, its determinant, how you get the determinant is, so you set it up like this here, but instead you have A, B, C, D, and determinant is always A, D minus B, C. So that's the determinant. That's how you figure out the determinant. So for this one now, we have V is equal to I, J, and K. I just write this on top here so you remember where to put each number, like which column each number goes in. So we have, for A, we have A1, A2, A3. For B, we have B1, B2, B3. And that is equal to, so we ignore the A1 and B1 for now, and we start off from A2. So the first one will be A2, A3, B2, B3, and that's going to be times I, which is equal to A3, A1, B3, B1, and that's times J, and that's equal to A1, A2, B1, B2, and that is times k. Now, the cross product. So after we do that, then we have to find, so what I told you just now with the determinant, so we go a2 b3, which is minus b2 a3, and we get a3 b1 minus b3 a1, a1 b2 minus b1 a2. The direction of vector v is perpendicular to both a and b. So let's do an example so you can understand it a little better. So in this example, vector a is equal to 1, negative 7, 1, and vector b is equal to 5, 2, 4. The cross product of a and b is equal to, I'm just going to replace all these letters here with these numbers. So in this case, a2 is negative 7 and b3 is 4. So I'm just going to replace it here. See, negative 7 times 4 minus 2 by 1, which is equal to negative 2 minus 2, which is equal to negative 30. Then we go 1 times 5 minus 4 times 1, and that is equal to 5 minus 4, which is equal to 1. Then we go 1 times 2 minus 5 times negative 7. So we get 2 minus 35. And we know a minus by minus is a positive, turns out to be a positive number. A minus by minus is a plus. So we get 2 plus 35, which is equal to 37. So the cross product of a and b in this case is negative 30, 1, 37. Types of vectors. Null or zero vector. Vector with zero magnitude. Null vectors can have any direction. Some examples are A, B, C, D, etc. A minus A is equal to 0. A is equal to 0, 0. B is equal to 0, 0, 0, 0. So you see they have zero magnitude. If you were to do x squared plus y, the square root of x squared plus y squared, you get the square root of 0 plus 0, which is equal to 0. So length equals 0. Size, length, size, magnitude equals 0. Unit vector. Vector with magnitude of 1. A unit vector is denoted by a lowercase letter with a hat. For example, I, and you see I with the hat on top of it. That's how it's represented. It doesn't have to be I. It could be U with a hat on top of it. It could be S with a hat on top of it. For example, vector A equals 3, 4. So now, if you look at this diagram here, you see, so one side of the triangle is 3, the other one is 4. So the X and Y, 4. Now, the length or the magnitude of A is equal to the square root of 3 squared, so of x squared, plus y squared, which is 4 squared, and that is equal to 9 plus 16, that's equal to 25. So now it becomes the square root of 25, which is equal to 5. So this side here will be equal to 5. And then, so now the unit vector I is equal to 3, which is x, over the magnitude of A, which is 5. So 3 over 5. And then you get 4 over 5. So that's equal to 3/5, 4/5. To check to see if it's correct, you find the length of the unit vector, because remember they said the magnitude of the unit vector is supposed to be 1. So once you get the answer equal to 1, you know it's correct. So let's see. We have the square root of x squared over the square root of x squared over 25, which is 3 squared over 25, plus 4 squared over 25, which is equal to 9 over 25, plus 16 over 25. 9 plus 16 gives you 25, so you get the square root of 25 over 25, which is the square root of 1, and that is equal to 1. So you know the answer is correct because the magnitude of a unit vector has to be 1. Position vector. Vector that has one end fixed to a body and the other attached to a moving point. Example OA, in which the O represents O00, which is the origin. So you see it's fixed at the origin here. So it starts at the origin, and then this is the moving point here. This could go on and on and on. So that's an example of a position vector. This displacement vector, the change in position, distance from starting point to the ending point. It not only tells you the distance, but also the direction. In the diagram below, AB is a displacement vector. Example of position and displacement vector. Points P, 3, 7, and Q, negative 4, 2, have position vectors 0Q, OQ, and OP relative to the origin. A. Express vector OP and vector OQ as column vectors. B. Express vector PQ as a column vector. And C. Find the length of vector PQ. So you see they gave you P is 3, 7 and Q is negative 4, 2. So what we do for A is just put that in column form. X goes on top, Y goes below. So it comes back to OP equals 3, 7. Vector OQ equals negative 4, 2. And for B, they wanted to also write vector PQ in column form. But first we have to find vector PQ. How do we find vector PQ? I'll show you the both ways which I mentioned earlier. So the first one that I chose was to subtract them. So the second vector minus the first vector, which is OQ minus OP, which is from here you see negative 4 minus 3, which is negative 7, and then you have 2 minus 7, which is negative 5. Or vector PQ is equal to PO plus OQ. We do not know PO, but we know OP. So what we can do is just find the negative of OP, which is negative 3, negative 7, plus negative 4, 2. So we have negative 3 minus 4, which is equal to negative 7. Negative 7 plus 2, which is equal to negative 5. And you see we got the same answer, which is negative 7, negative 5. And now for part C, they asked us to find the length of vector PQ. To find the length is always the square root of x squared plus y squared. So in this case, x is negative 7 and y is negative 5. So we have the square root of negative 7 squared plus negative 5 squared. And negative 7 squared is 49, negative 5 squared is 25. So the square root of 49 plus 25 is equal to the square root of 74. And that is your answer. That is the length of vector PQ. Equal vectors. Vectors that have the same magnitude and run in the same direction. They may start at different positions. When vectors are equal, their directed line segments are parallel. So you see this diagram here, the line segments, they are parallel, meaning that they are of equal distance the entire way, equal distance from each other the entire way. And you see they're pointing in the same direction, same size, therefore they're equal vectors. For example, vector A, it's 1, 2, and vector B is 1s. If they're equal vectors, what is x? Sorry. So you know they have to be the same numbers, the same, because everything has to be the same for them to be equal vectors. So therefore, A1 has to be equal to B1 and A2 has to be equal to B2. In this case, A1 is equal to B1, which is equal to 1. You see they're both 1. And then B2 now, A2, sorry, has to be equal to B2, which is S. So we're solving for S now. So we know A2 is equal to 2, and B2 is equal to S. Therefore, S is equal to 2. Opposite vectors. Vectors that have the same magnitude but run in opposite directions. The sum of opposite vectors equal 0. So you see these are opposites. They have the same size, but they run in opposite direction. This one is heading that way, this one is heading downwards. For example, if vector AB is negative vector of vector CD, if vector AB has the same magnitude as vector CD, but are opposite in directions. So you see vector AB is equal to 3, 2, and vector CD is equal to negative 3, negative 2, which means the negative 3, 2, which means the negative of AB. So therefore, AB is equal to negative CD, and negative AB is equal to positive CD. AB and CD are negative of each other. And if you were to add both of them, you will get 0, because 3 plus negative 3 becomes 3 minus 3, which gives you 0. 2 plus negative 2, same thing, gives you 2 minus 2, which gives you 0. So see, the sum of the opposite vectors equals 0. So you know they are negative of each other. Co-initial vectors. 2 or more vectors which have the same initial point. Example, vector AB and vector AC are co-initial vectors since they have the same initial point. See, they both start at A, point A. So AB, AC, same initial point, which is right here, which is A. Parallel vectors. Vectors which have parallel supports. They can have equal or unequal magnitudes, and their directions may be same or opposites. So these are some diagrams here just demonstrating different parallel vectors. See, these are going in the same direction, they look approximately same size, and they're not touching at all, they're equal distance all the way, makes it parallel. Same thing here, but well, this one, these are different sizes and opposite directions, but equal distances apart. Here, different size, same direction. So on opposite directions, different sizes. So yeah, these are all diagrams showing parallel vectors. Two vectors are parallel if they are scalar multiples of one another. If u and v are two non-zero vectors and u equals cv, then u and v are parallel. So you see c in this case represents the scalar or the multiplier. AB equals k CD, therefore AB and CD are parallel. So just showing that AB equals K times CD, which makes it parallel. A equals KB. K is a constant not equal to 0. Let A equals AX, AY, and B equal BX, BY. A and B are parallel if and only if A equals KB. So we know it's only parallel if A equals KB, and we know A is equal to AX, AY. So we're just going to, and B is equal to BX, BY. So we're just going to replace A and B with AX, AY and BX, BY. So we get AX, AY equals K times BX, BY. And this part here, K times BX, BY, we just multiply K by everything that is within these brackets. So we get K times BX, which is KBX, and K times BY, which is KBY. So now we have AX, AY equals KBX, KBY. So now we know AX has to be equal to KBX and AY has to be equal to KBY. Or we can make K the subject of the formula. So if we have AX equals KBX, in order to get K by itself, we need to divide both sides by BX. So it becomes AX divided by BX equals K, which is what we have here. And we do the same thing for the second part, which is AY equals KBY. We divide both sides by BY and we get AY BY equals K. Condition under which vectors A equals AX AY and B equals BX BY are parallel is given by AX divided by BX equals AY divided by BY, or AX BY equals BX AY. And how we get that? If you want, well, we just showed you above here, but if you have AX BX equals AY BY, you just cross multiply. So you get AX times BY, that's how they got AX BY, and that is equal to BX times AY, which is BX AY. Example 1. A, which is 0, 2, 3, B, 4, 7, 1, C, 3, 6, 9, and D, 15, 21, 3. Prove AB and CD are parallel. So vector AB is equal to B minus A, which is 4, 7, 1 minus 0, 2, 3. So we do the first values. So 4 minus 0, we get 4. 7 minus 2, we get 5. 1 minus 3, we get negative 2. And for CD now, we have D minus C, which is 15, 21, 3 minus 3, 6, 9. So we have 15 minus 3, we get 12. 21 minus 6, we get 15. And 3 minus 9, we get negative 6. So now we have to compare both and see what can we do. Is there a number that can be multiplied by this vector in order to get 12, 15, negative 6? I know that 4 times 3 gives you 12. So now I'm going to try multiplying 3 times all of these numbers to see if I get 12, 15, and negative 6. So we go 5 times 3 is 15. Negative 2 times 3 is negative 6. Therefore, that is equal to 3 times 4, 5, and negative 2. What we can also do, if you can't look at it and see that you can multiply by a certain number, you can also try dividing. So you go from the bigger number and then divide by the smaller ones and see if it equals to the same number. So 12 divided by 4, you get 3. 15 divided by 5, you get 3 as well. And negative 6 divided by negative 2. Negative divided by negative is a positive. And 6 divided by 2 is 3. Therefore, 3 works. It's correct. So that means 12, 15, and negative 6 is equal to 3 times 4, 5, negative 2. So CD, vector CD, is equal to 3 times vector AB, which means they are parallel. Example 2. Which of the following vectors are parallel? So we have vector A equals 2, -3, vector B equals -6, 9, vector C equals -1, -2. The condition for two vectors A is equal to AX, AY, and B is equal to BX, BY to be parallel is AX, BY equals BX, AY, as mentioned a couple of slides ago. So I know it says A and B here, but you could also do the same with C. Those letters are just letters that they use. It could be C, it could be D. It doesn't have to necessarily be A and B. So for this case, we're going to work with A and B first, but we also have to check B and C and A and C. So for vectors A and B, we have AX, BY is equal to 2, because AX is 2, times BY, which is 9, and we get 18. BX, AY now is -3 times -6. Negative times a negative is a positive, and 3 times 6 is 18, which is the same as what we got for AX, BY. Therefore, vectors A and B are parallel because they are equal to each other. Now let's try A and C. So we have AXCY equals 2 times -2. A positive times a negative results in a negative, so, and 2 times 2 equals 4, so the answer there is -4. CXAY equals -1 times -3. Negative times a negative is a positive, so we have -1 times -3, that is equal to +3. Vectors A and C are not parallel because -4 is not equal to 3. Therefore, AXCY is not equal to CXAY. So they are not parallel. Vectors B and C are not parallel since vectors A and B are not parallel, but let's still test it. BXCY is equal to -6, negative times -2. And as I said before, negative times a negative is a positive. 6 times 2 equals 12, so therefore we got +12. CXBY is equal to -1 times 9. A negative times a positive is a negative. Therefore we get -9. So as you can see, 12 is not equal to -9. Therefore, BXCY is not equal to CXBY. So B and C are not parallel. Collinear vectors. Two or more vectors which are parallel to the same line irrespective of their magnitudes and direction. So size and direction doesn't matter. It could be different sizes, different direction, but once they are parallel to each other or on the same line, they are collinear. These are some diagrams to show you. So you see these have two different magnitudes, but they're going in the same direction and they are parallel. So it means they're collinear. These are also parallel, opposite direction, same size, different sizes, same direction, but on the same line, parallel. These are also going to be on the same line, and these are same direction, same size. So these are all examples of collinear vectors. Vector AB is equal to K times vector BD. Therefore, AB and BD are collinear. They both have a common point, which is B. Their cross product will be 0 since the angle between the two vectors is either 0 degrees, which is the same for the same direction, or 180 degrees for opposite direction. Example 1. A is 2, 3, 5. B, 3, 6, 7. C, 6, 15, 13. Prove A, B, and C are collinear. Vector AB equals B minus A, which is 3, 6, 7 minus 2, 3, 5. You get 3 minus 2 is equal to 1. 6 minus 3 is equal to 3. 7 minus 5 is equal to 2. So for vector AB, we get 1, 3, 2. Then we have vector BC equals C minus B, which is 6, 15, 13 minus 3, 6, 7. We have 6 minus 3 is 3. 15 minus 6 is 9. 13 minus 7 is 6. And now, as I said before, you look at both of them and see if we could figure out what number times these smaller numbers will give you the bigger one, or we can divide. Let's try multiplying first. Well, we know 1 times 3 equals 3, so now we could try 3 for all of them and see if it works. 3 times 3 equals 9. 2 times 3 equals 6. Let's try the opposite way, dividing. 3 divided by 1, we get 3. 9 divided by 3, we get 3. 6 divided by 2, we get 3. Therefore, 3, 9, 6 is equal to 3 times 1, 3, 2, and 1, 3, 2 is the same as vector AB. Therefore, BC is equal to 3 times AB, and that means AB and BC are collinear. Example 2. Prove A, 2, 3, and B, 4, 6 are collinear. So ABCD equals 2, 3, 4, 6. AD minus BC, remember what I mentioned about the determinants earlier. So AD, which is 2 times 6 minus 3 times 4, you get 12 minus 12 is equal to 0. Therefore, A and B are collinear. Perpendicular vectors. Two vectors A and B are perpendicular if and only if their scalar product is equal to 0. Also, they form a right angle. See, perpendicular means forms a right angle. As it shows in this diagram here, right angle means it forms like a 90-degree angle right here. Let A equals AX, AY, and B equals BX, BY. Vectors A and B are perpendicular if and only if A dot B equals 0. So just replacing A and B with AX, AY, and BX, BY, which is, now it becomes AX, AY dot BX, BY. How we do this? We multiply. So you multiply the x by x and y by y. So we have AX, BX plus AY, BY, as we have here. So AX, BX plus AY, BY. Hence, vectors A and B are perpendicular if and only if AX, BX plus AY, BY equals to 0. Because that shows you that A dot B equals 0. And after working it out, we saw that AX, BX plus AY, BY equals 0. So that's how you prove that the vectors are perpendicular. Example. Find the real number k so that the points A, 2k, and B, 2, 3, and C, 2k minus 4 are the vertices of a right triangle with right angle at B. ABC is a right triangle at B if and only if vectors BA and BC are perpendicular. And two vectors are perpendicular if and only if their scalar product is equal to 0, as mentioned before. Let us first find the components of vectors BA and BC given the coordinates of the 3 points. Vector BA equals 2 minus 2 and k minus 3, which is equal to 2 minus 2, we get 0. K minus 3, we can't solve that yet because k is a letter and a letter cannot take away a number. So we have to leave it as is for now. And vector BC is equal to 2k minus 2 and negative 4, negative 3. Same thing here, 2k minus 2 cannot be broken down as of now because k is a letter. So we leave it as 2k minus 2, and negative 4 minus 3 gives us negative 7. The scalar product BA dot BC is equal to 0 is written using the components of the two vectors. So we have now 0 times, because BA, 0 times 2k minus 2 plus k minus 3 times negative 7. So from this first one, 0 times anything gives us 0. So you have to say 0 times the x value of 2k, you get 0. Minus 0 times 2, we get 0. So that works out to 0. Plus negative 7 times k, we get negative 7k. Negative 3 times negative 7, positive, a negative times a negative gives us a positive, and 3 times 7 is 21. So that's how we get negative 7k plus 21, which is equal to 0. So now we want to put the like terms together. So we want to get letters on one side, numbers on one side. In order to get 7k on this side by itself, we have to minus 21 on the left hand side here, and because we do it on one side, you have to do it on the other side to balance it off to keep the equation equivalent. So we get negative 7k on this side is equal to 0 minus 21, and 0 minus 21 is the same as saying negative 21. So we get negative 7k equals negative 21. Now in order to get 1k, we need to divide this by negative 7. And because we divide by negative 7 on the left-hand side, same rule applies. So we have to divide by negative 7 on the right-hand side. So we get k is equal to 3. And the reason it's a positive 3 because a negative divided by a negative gives us a positive. 21 divided by 7 is 3. So k is equal to 3. So from this, we will see that the vector BA will be equal to 0, 0, because k is 3, so 3 minus 3, we get 0, so 0, 0, so it's actually the origin. And vector BC now will be 2k times 3, which is 2 times 3 minus 2, so that becomes 6 minus 2. So we get 4 here, and then negative 7. So vector BA would be 0, 0. Vector BC would be 4 minus 7. Given vector U equals negative 2, 5, find the equation of the line through point A, which is 2, 2, and parallel to vector U. The equation of the line through point B, negative 3, negative 4, and perpendicular to vector U. So we're going to try these problems. This problem here, let's see. So A, we have a point M, which is xy, is on the line through point A, 2, 2, and parallel to vector u, which is -2, 5, if and only if the vectors am and u are parallel. So we have am is equal to, so am now, remember we have to do the first, so it's going to be the second vector minus the first vector. So that's why we have x here minus 2 and then y minus 2. So you get x2, y minus 2, x minus 2, sorry, y minus 2. So now vectors am, which is equal to x minus 2, and y minus 2, and u is equal to -2, 5 are parallel if and only if ax by is equal to ay bx. So now, what is ax? Ax is x minus 2 and by is 5. So we have x minus 2 times 5 is equal to ay now is y minus 2 and bx is -2. So we have is equal to y minus 2 times -2. And how we do this? We multiply the 5 by everything that's in this brackets here. So we have 5 times x, which gives us 5x. We put back the same sign, which is the minus sign, and 5 times 2 is 10. So we get 5x minus 10 is equal, always put back the equal sign. And now -2 times y gives us -2y. And -2 times -2, remember, negative times a negative is a positive. So we get 2, and 2 times 2 is 4, so we get +4. So now we have 5x minus 10 is equal to -2y plus 4. From here now, try to get like terms together. So letters on one side and numbers on one side. However, we know the equation of a line is y is equal to mx plus c. So we always try to write it in that form. So you try to get the y on one side and then the x and the number on the other side, on the right hand side. So we already have, we have the x on the left hand side but the y on the right hand side. So we want to try to switch that. So in order to get the y on the left hand side, we have to add 2y on this side. So we have, so on the right hand side we have -2y plus 2y plus 4. That gives us 0 plus 4. So we get 4 alone on this side. On the left hand side we have 5x minus 10. And then you add 2y to that. So we get 5x minus 10 plus 2y is equal to 4. And now we have 5x minus 10 plus 2y equals 4. So now we want to get the 5x and the 10 on the other side. In order to get 10 on the right hand side, we have to add 10 on the left hand side. Therefore, we add 10 on the right hand side. And we have to minus 5x on the left hand side and then minus it on the right hand side. So we get 2y is equal to -5x plus 4 plus 10. And now we can add these values. So it becomes 2y equals, sorry, this is supposed to be a -5x, not positive, it's -5x plus 14. So the answer is 2y equals negative 5x plus 14. And for B, now we have a point M, xy is on the line through point B, negative 3, negative 4, and perpendicular to vector u, which is equal to negative 2, 5. If and only if the vectors bm and u are perpendicular, bm equals, so that's going to be the second vector, which is m minus the first vector of b. So you get x minus minus 3 and y minus minus 4. And minus by minus is a positive. So we get x plus 3, y plus 4. Now vectors bm is equal to x plus 3 and y plus 4 is, and u is equal to negative 2, 5 are perpendicular if and only if ax bx plus ay by equals 0. So now we have ax is equal to x plus 3, bx is equal to negative 2, ay is equal to y plus 4, by is equal to 5, and those two plus each other is equal to 0. So now you multiply throughout. Let's see, negative 2 times x, it gives us negative 2x. Negative 2 times 3 gives us negative 6. Plus, so you put back the plus sign, 5 times y gives us 5y, plus 5 times 4 gives us 20. And all of that is equal to 0. So now we want to get the numbers and the x value on the right hand side, and we want to leave the y value on the left hand side. So seeing that the y is already on the left hand side, we leave it as 5y there, and that is equal to, let's move the numbers first. So we have negative 2x plus 5y plus 20 minus 6. So 20 minus 6, we get negative 4. We got positive 14. So now we have negative 2x plus 5y plus 14 equals 0. In order to get that 14 on the right hand side, we need to minus 14 on the left side as well as minus it on the right side. So we have negative 2x plus 5y plus 14 minus 14 equals 0 minus 14. So that becomes negative 2x plus 5y plus 0 equals, and the right hand side, 0 minus 14. The answer will be negative 14 on that side. And we don't need to write a 0 on the left hand side because anything plus 0 is 0. So we have negative 2x plus 5y equals negative 14. Now we want to get the 2x on the right hand side. So in order to do that now, we need to add 2x on both the left and right hand side. So we have negative 2x plus 2x plus 5y equals negative 14 plus 2x. So now negative 2x plus 2x is equal to 0. Then we have 0 plus 5y equals 2x minus 14. And 0 plus 5y just gives us 5y. So the answer to that would be 5y is equal to 2x minus 14. I hope these questions help you. It's pretty simple. Just have to be careful with the numbers and letters. And make sure, just remember the equation of the line is normally y equals mx plus c. So we just rewrite it till it becomes that form. And that's all I have for you today. Hope this was helpful. Have a good day. Thank you.